Hi, I'm Tom Kaler, and this is a overview of kind of the background and foundation for generative collective intelligence. And really, this is about orchestrated dynamic learning. It's a very different way to be thinking about AI. And we started this about 10 years ago, thinking of how do we use the current language processing technology introduced by transformers and these very sophisticated language models? How do we use that to help groups learn and work together to be able to be more productive in their work? But the task was not to use AI as a product, but to use AI as a assistant, a facilitator in a dynamic learning process. And this is the fundamental difference when we talk about generative collective intelligence. When you're looking at an AI model, it's the result of months of training. When the training is done, it's post-processed to be usable, kind of QA'd, and then you use it like you do now. And then there's an announcement about a new model, which may come out many months later. That's because the training process is long, expensive, and difficult. What we're talking about is radically different. It is a transparent learning process as opposed to uh, a black box learning process, which is the learning from text. And it is transparent and explainable, and participants in this process are able to see it emerge and evolve as you do it. So we're going to be thinking of AI as a way to guide us. Now, why is this valuable? Well, now in a time of AI agents, we have to figure out how all of these agents are going to work together. So while we started out looking at this as a task of harnessing collective intelligence, it naturally and is actually is fueling our next generation. Is an ability to integrate agents into a collective learning process. So again, remember, this is about dynamic learning. Now, this is not brand new to you. If you have used Google, you have been a participant in teaching a system to get smarter every time you use it. You can't see it as much now as you could when it first came out roughly 20 years ago, when uh, there was in the beginning of Google, and it's probably a little bit more than that, the very beginning of Google, if you used it, you would not see all of a sudden it home in on exactly the right answer right away. That's because as people used it, it was getting smarter and smarter based on your feedback. So here's what happens when you would click on a link, that would train the system. Oh, that's important. And just over and over again, it was adaptively learning what everyone wanted. Now, this is what was magical about Google search as opposed to all the other products because it adaptively learned. The reason being, underneath it was exactly the same kind of thinking and model we're going to use for generative collective intelligence. Underneath it was some fundamental mathematics, which Markov processing and a thing called the Perron-Frobenius theorem, which kind of guarantees that things will converge. That's what's underneath Google. And that has kind of been lost with the commercialization and the motive, basically you can pay your way in, et cetera. But in the beginning, this paper that was published in 1999 of bringing order to the web, we can use that same idea to bring order to how we work together. Now, it just so happens that these kind of algorithms, or I was actually involved with a group before PageRank was uh, filed for a patent. We filed for a patent on adaptive learning, applying it to how do we learn the preferences of groups. So this is something we've been working on in different companies for over 30 years, actually. And so the point here is what we're going to be looking at is a very different way of thinking. It's adaptively learning, and I want to keep you that in mind. It's really hard to imagine that, and when people have used the product of CrowdSmart, they have said, well, "Where's the AI?" Well, it's actually in the background. And that's frankly, I don't even like the term AI that much because it probably is a little bit misleading. And we're kind of going through that right now. But let's now look at why do we need a path guider? Why do we need a pathfinder? Why do we need a navigational aid? Well, this we live in perpetual uncertainty. Unlike almost any other time in history, because of the availability of information, et cetera, we have so much going on that it's really slowed down our ability to act in a way that we're able to deeply listen to people who are involved in a problem-solving process. So we end up with analysis paralysis or tyrannical kind of moves, top-down moves of decision making. This is unproductive because if you do a top-down decision, you have a lot of unhappy people, a lot of free energy. If you do a bottom-up decision, it is very hard to be able to make that happen because there's a couple of fundamental problems that we have to solve. So learning from data does not help this because that only tells you plausibilities of how people might agree. We need to know how do we dynamically adapt and learn from each other so we change our points of view as we learn together so we become aligned. That's really the goal here. If we want to have action, and this is both corporate and social, if we want to have action, the groups that learn together then became very tightly high performing uh, groups together because they're aligned in their beliefs about what creates the outcome. So every little single step is going to be important here in this learning process. So the second thing that's going on is the amount of entanglement of these decisions has gotten very, very complex. One decision affects another. We also have distributed teams. Collaboration has become really, really difficult. That is, collaboration of the form that results in conclusive outcomes. We have a lot of ability to share information, but it's mostly dispersive. It's mostly exploratory. It's mostly ideation. And let's call into attention here to go from creativity to innovation, that is, putting something into practice, a policy into practice, a product in the market, going from the idea to the actual fit and finish, product market fit, get it out and go. That's a very different process. That latter process of innovation requires uh, compromise. It requires solving problems all along the way. That's what we need a path guiding system for. So think about this as a continuous learning environment that can help us think together. This means we have to have a profound change in how we think about AI. It is a learning system, an intelligence amplification system. And this is fundamentally a just a different way to look at it. And I think what we want to do is really think about how intelligence is, humans being a group, how intelligence is work together to create uh, output and actions and new knowledge. So the whole process here is automating knowledge acquisition, learning and automating knowledge acquisition. Now, before we go into this, I'm going to do a shift here of let's not keep thinking about AI in general. There are some really simple underlying principles that can be extracted if we step back and see where does this all come from? This all derives from statistical mechanics and mathematical physics. If those are practitioners are very aware of this, is you see the terms that are borrowed from thermodynamics and physics all over the place. This has also been recognized in transformer models. There's a paper, and I address this in a longer paper I have, which you can see on ResearchGate, is that transformers really can be modeled in physics of particles interacting in a field. I'm not going to go into detail on that, but here are some of the fundamentals you get out of when you work with an information physics model. Really, what you're learning are just like uh, learning order from the web was finding out what are the characteristic modes of what would describe what's resonating with the audience, what is important to the audience. Those are rankings. And when we talk about page rank, those our rankings of the characteristic values are called eigenvalues or resonance modes. What's resonating with the audience? And so when you look at a ranking, this is just what resonates most, what resonates second most. So when large language models learn, they're learning the resonance modes of concepts and ideas within data and documents. So the way they're trained is you give it a massive amount of data, you run it through the transformer model technology to do its thing. And in the case of LLMs, this may be a many month process. And out the other end comes a wide spectrum of all of the different concepts, but ranked in order of importance. And this makes LLMs able to do things like with your prompt engineering, you come in with a concept that you're looking for clarity on, it's able to find that concept and then begin to do projections from that. So reasoning in an LLM is simply just looking at how to assemble concepts. Doesn't really have a deep understanding of anything, but it really knows how to do the math with those concepts. That, by the way, is what leads to hallucinations, but we'll leave that alone for a minute. So when we want to now look at the difference here of how we're going to use transformers, transformer models are turned on data. When we do generative collective intelligence, we use the transformer models, part of it, to just simply use it to understand, use it in a knowledge learning acquisition process to manage the dialogue of humans interacting in natural language. So we can, if we say, hey, I think we ought to launch this product, and here are all my reasons why, that now becomes manageable within this kind of environment. And so we now have opened the door to something we never had before, which is a way for an AI to be a dynamic learning environment for teams of people working together. So the shift of generative collective intelligence from generative AI is bringing in teams of decision makers. And essentially, this is a critical transition that must happen if it's going to be used effectively and trustworthy in a trustworthy manner in corporations or in societal applications. Let me give you an example of why this would be applicable to a corporation. And this is something we actually did a few years ago. Worked with a large company. They had an idea of going into a new industry sector and use that to draw business on their traditional product. We were able to pull together a group of about 30 people who had deep knowledge in the target industry, and we were able to do a generative collective intelligence review of that product from a variety of points of view. Now, the result was not very positive because it was not well developed just yet. However, what the group was able to do was offer, and we could provide this knowledge back to the corporation of these are all the suggestions they had of how to move it towards product market fit. So you can see how this sort of dynamic learning can radically change how we understand quickly what products are necessary in the market. So let's move on now to what is the big problem we have to solve in this? Well, the big problem, if you have 30 people and we were to do that same thing, talking to each one, say what was their idea, and then, but here's the important thing for deep listening. It's not just that one person's idea, it's figuring out, well, how did this other person, say person number two, their ideas, how do they affect you? Did you learn something? If you learn something, that might change what we all think may be the right way to do this, right? So we can, it's just like we do in a learning session together. We say, oh, wait a minute, your thought changed my thought. What this approach does is it captures that. Now, to do that is hard. In fact, it's not possible without a major change. And here's the reason. If you have seven people in a room trying to do deep listening to each other, they have 21 lines of communication that have to be managed. That's a lot. And in fact, if you even just do some of the math on that, it means this is why when we have these kind of meetings, they get long, we get weary, and we decide whatever you want to decide, go because we're just tired. And the problem with that is that now when you begin to take this to things like uh, dynamic learning from a community of thousands of people, it becomes an impossibility until you can do the approach that we're going to present right now. You can break that barrier by moving from serial communication to parallel. Now that we have a language understanding system, we can listen to an audience in parallel. So, what does this mean? This means that we can now take a group, and I just showed the photograph here of a group in a brainstorming meeting with yellow stickies on the wall and all that good stuff. And that's typically what we do. When we have a big problem, we get together and say, okay, let's put everybody's ideas out there and then let's figure out where are we aligned. Now, and someone might say, hey, why don't you just take all of that data? And I know people are doing that right now. In fact, there are products that offer this. Hey, let's just take all that data, run it through an LLM, and it's going to tell us what to do. Wrong. Because all it's going to do is give you and if you've done this, you've experienced it. It's a general summary. It's a little bit helpful. It does not lead to decisive action because you don't know what are the trade-offs between the different people in the room. You don't know, do they really agree or not? You don't know if they're just participating or not. What you have to sample is how does one person agree with another person's idea? How did one person's idea change someone else's idea? That dynamic learning can now be done. And what we do in generative collective intelligence is this is actually from a CrowdSmart engagement we did in the investment sector. It builds a web that monitors how people exchange information. The user experience, think of it as like a kind of super Quora or super Slack or something. The difference being there's going to be one additional step. You share your idea. Now we're going to have you deliberate and looking at the ideas of other people that are in that group. But we're going to do it without identity. We're going to do it online in parallel prior to an in-person meeting. What's going to come out and what does come out of that wheel you see here in the center is a lot of information because they now have the same structure as Google used for PageRank on the web. We have a structure that says we can now learn the resonance modes of the group around how they think about very specific questions. So that's what it comes out. So the big idea comes out at top, next big idea, et cetera. So now when they go into the in-person meeting, they already know kind of a cognitive map of where everybody stands so they can start talking about what are the solutions we want to create together. Again, we did this, and I blanked, the middle there is blanked out because I'm not going to show you NATO data, but this was some work we did with NATO around how do we streamline decision-making processes across 31 countries, many participants. In this particular engagement, we had over 100 participants generate 3,000 ideas, and the system resolved to, and you see that curve on the right, that is the ranking distribution. It's a power law for those who are math. It's the Pareto distribution. It basically learns what's important to the group very quickly. This is really came out of a couple of hours. The math on getting that out of 100 participants is not possible any other way. What is different about this too, this is not simply saying, hey, here's a bunch of ideas, everybody vote. No, this is a continual exchange process for everyone had to some degree an opportunity to see what other people are thinking. Now it's doing this with a Bayesian sampling. So it's only sampling some things, but we are doing inference every step. So you can very quickly get to models that converge. Now, so that's the breaking of the back of a problem that has kept us for a long time from collaborating. And it also has moved us to very different structures where we say, hey, look, people at the top have got to make the decisions. Not necessarily anymore. And we have done some work with Bain, and they had a rule of seven, which the woman who invented that is Marcia. Kind of looked at this as, hey, that rule of seven, we don't think we need to have anymore because rule of seven said this: anytime you add one person over seven to a group meeting, you're going to decrease the productivity by 10%. And here's why. If you have 10 people, you give each of those people 3 minutes to share their idea, and then maybe a couple of minutes to listen to others, and that's not enough. Even at that, it's 2 hours. And in 2 hours with 10 people deliberating over something, even a few questions, you're exhausted and the creativity is not there. If you do this with the method I just mentioned, Bayesian mechanics, and we won't get into the math of all this, but that's in another video. But if you do that, you end up doing it in 10 minutes. Now, here's the magic. You move it to 100 people, 10 minutes. Same thing. Uh, it could be a little bit more, but the point is it is roughly uh, you can now scale to 1,000 people, and we've actually done this. We're inviting a city that's doing budget planning, and we had thousands of people participate, uh, and it was able to resolve to what are the top resonance modes about issues on the budget for that city. So the other thing that comes out of this, once you have these interactions, what's important here again is monitoring how people are learning from each other. The fact that every time someone puts something in, that changes the system, which changes what the next person sees. So this is facilitating a learning process, and out of that comes some other very powerful things. The influence, something we call influence rank, which says we now know, just like in any citation network, it just works in science all the time, we now know in that category who is cited most, who is cited second most. So that tells us if we're having a topic about launching a specific thing or a product or a decision in a specific area, we can say who has the most knowledge respected by other people in that group. So you can immediately detect thought leaders. You can imagine the value of that for corporations or in societal chains. You can find out who the thought leaders are. You can also find out who are the people who are most likely to be listeners. These are people, engage rank is essentially the people who spend more time listening to others, reaching out and citing other people's work than their own. So you can see here now we've replaced the notion of websites with people or AI agents. By the way, this you can now, and we didn't start out with that idea, but as AI agents came along, it was a simple thing to say one of those nodes doesn't have to be a person, it can be an AI agent. The whole thing could be AI agents if we wanted to. So this provides a way of facilitating collaborative learning and automated knowledge acquisition. And by the way, this also, we can then create a knowledge economy here because we now have an incentive system. We know who contributed to some output. If we have output of value, we can now apply that back to the participants. We actually did that for a period of 4 years, running what was in effect a small investment uh, 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 community. It was kind of a DAO, and we used that to where the participants actually received a piece of the carry of those investments from their participation in this kind of activity, where they were participating in evaluating companies. So we actually looked at this as a way to take that to the next level. It was very early. It was But it gives you a sense of the potential of this going forward. Now, what is coming out of this as well is in the back end. Now that we know what is relevant to the group and what is driving these scoring patterns, we can now construct a network of causal relationships. Human beings are all about cause and effect. I know this company will do well or this product will do well because I have a lot of trust in the team or whatever that might be. We think cause and effect. We don't think pattern recognition from data. Like when you're training a transformer model, it's just simply looking at data. Human beings operate in a very different way in terms of this causal modeling. And if you want to learn more about that, look at Judea Burrell's book called Why. But what the system is actually doing is extracting a computational model of the entire knowledge that went into that particular, in this case, is an investment decision. And this can be used then with data. It'll score, data from a Zoom transcript, which is what's on the left there. Now, that wasn't particularly accurate, but the point is it gives you an idea of what the potential is here. You're able to take the cumulative IQ of teams in a corporation or teams in a community and be able to capture that knowledge and then use that in a variety of other ways. Now, the other thing that's going on here, this generates a very different kind of language model because this particular language model now is highly contextualized. We know exactly what question they were asking. We know we have time series data on what was the context and when they were having this discussion, and all that gets labeled or annotated as metadata into the model. So by the time it's in generative mode, it is now generating from a much richer provenance base than you see in LLMs. Now, this also gives an indication to how a corporation could begin to construct highly customized LLMs where they don't have to share that knowledge with the entire world, or communities could do the same thing, or um, defense organizations could do the same thing. Now, where do we want to go with this? Well, uh, as you can, we've done this over the last 10 years, and as we were going through it, probably about 2, 3 years ago, when ChatGPT came out, we recognized, hey, this works. You can start introducing AI agents into this. Now, why do that? Well, first of all, everyone knows there's a serious hallucination problem. So, how do we admit what is coming out of a generative AI into a societal or corporate situation? How do we move from AI as personal to AI as facilitating uh, social dynamics or corporate dynamics? How do we do that? Well, the only way to do that is to have a system whereby we can begin to reason together. So we call that collective reasoning. That may not be the best term for it, but the idea here is the dynamic learning process that goes on can be instrumented and measured and managed. The next few slides get into some of the details. There is also another uh, YouTube video I've done on this where I really get into the information physics. But let me just quickly go through this to say what's happening is the learning algorithm is moving from exploration to convergence and prioritization. So it's literally, once it's figured out that it's explored the space of options, and there's a way to actually do that routinely, it explores the space of options around any particular problem and then begins to listen to the group and guide it towards a prioritized output. In other words, we're kind of trying to find out what is the best way in terms of minimizing the uncertainty and finding out where the group lands. It literally helps solve that difficult problem of getting groups to converge and doing it in a way when it's asynchronous and not in person removes a lot of the potential politics and bias and can move a lot faster in that direction. So what we believe the output here is going to be is increasing agility and innovation at scale. Um, but keep in mind, at every step, every time you put an input in or someone else does, the system takes that into account and that affects the next step. So this beta sampling algorithm, I use the term beta because alpha is about power, beta is about knowledge in my mind, and so that's kind of where we go. Now, at every point here, it's developing a Markov model where it's a memory. So Markov models can say, okay, I know what the state of the system is now. It can generate. And so that's what the system is adaptively learning at every step and able then to use that knowledge as to what it's going to suggest in the next step. So the Markov model is kind of a knowledge walker through the dynamic learning and reasoning process and following the citations and semantic connections and essentially detecting resonance modes at every step and using that to guide the conversation and out the other end. Uh, Comes a result. And what you see here on the right is it may start out where we have loads of ideas, like we did in the case of NATO, and it'll then resolve to a few resonance modes that are of importance with the group. And human facilitators do this, but it's hard. And it's also limited to the size of the group. And even there, you're going to end up with a few power leaders in a group that probably drive that process. But this is a way to open it up and take it to a much broader audience. There is also an ability to map the actual knowledge base. This is a 3D representation of what is going on in the collective mind. But what we're doing here, and for those of you who are interested in have a connection to what is going on in the AI world around looking at quantum field theory, what this sets it up is this is a way to map into Hilbert space the a model of the collective mind. And this has immense power in where we can take this. So from the user experience point of view, I know the screen is very full, and this is not I'm going to have another talk on just showing how you can do this. But basically, you get an email, you get an invitation, or you get a link on a website or whatever. You click on the link, you get an opportunity to explore the topic, and then you can peer review what other people are saying or add your own contribution. You can look at the emerging language model, and when you peer review, you get like 7 items, and you say, "Hey, I love that," or "I don't." You don't have to respond. You can get another list, but it gives you a way to interact. The other thing we're developing around this is a notion of kind of like a jazz session with cause and effect of give people an ability to go in and jam with each other on ideas around solving a problem. So you see three little things, responses there can be a flag which says, hey, wait a minute, I think this may be a hallucination from an AI model or a colleague. Uh, and the second one there is I can actually send a message to the person who created it, even though I don't necessarily see their identity. I can send a message to them and find out a little bit more detail, and that's all tracked. I can also build in their idea, and this is where serendipity can get unlocked. The whole reason to do this as a collaborative learning environment is the world will go to some degree uh, to where we have to collaborate with larger and larger groups. This gives us the ability to do that. And the larger the group, the higher the chance that somebody's going to come out of the woodwork here and say, I just saw three different ideas that I can pull together into a brilliant new idea. There is no other system right now that allows us to do that at scale. I believe there will be many as we develop out generative collective intelligence. And by no means am I saying that because we had an early start on this, we're going to be the only players in that category. But the whole point of what this video is about is to encourage further development in this area. So collaborations, you can think of them as a different kind of Wikipedia where you may put a model out there where we can reason together about possible brainstorming solutions. That's an idea. Once you know the interaction, there's all kinds of data that you can extract. Uh, Understanding how the learning process evolves over time is very important. And there are various metrics we can pull from information physics for this. One being free energy, which is what this thing at the top here is about. It's basically saying as the attention parameter moves from exploration to convergence, you can see there's been variation in the free energy and then it levels out. That doesn't mean uh, everyone's going to agree. It just says how close have we come. The other thing we can discover are knowledge pathways, places where there might be areas for agreement. Well, we can look at trust networks. I mean, how much do people trust if we are using agents, how much do people trust them, or how much do they trust each other? It can also generate a new kind of knowledge graph, which is already annotated with what the group mind thinks of. This is essentially a knowledge graph that incorporates the group mind. So the general idea here is to bring cognition into the main stage. Cognition has been used in generating these LLMs. It was, after all, it's crystallized cognition in the documents. It's basically those documents were generated out of human cognition. We used human cognition in the reinforcement learning and training process, aligning the models. DeepSeek has shown that cognition can radically drop the training costs. This is a way of, in a principled way, bringing in cognition as a first-class citizen. And I'm not saying that, I'm not even making the assertion here that, uh, something about what is the most intelligence in the group. This is just a way to manage a collection of intelligences. But what it does say is this is the pathway that I think we can start to bring in. In fact, this is largely based on a model that has solid roots in neuroscience. And so we can start to expand the notion of what we're thinking about intelligence. And I would prefer that we just move to thinking about intelligence amplification in my own humble point of view, because I think that will lead to progress at a time when we really need progress in how we can be more agile and innovative in the way we listen, learn, and act. Thank you very much. Oh, I'm sorry. I meant one other thing. I'm going to put an API together that should be available over the next few months, where we're going to make a lot of this available through some metered facility so this can be used in integration with other application frameworks. So one of the ideas here is this is enabling technology for a lot of different applications. So again, thank you very much.